So that's a no, don't tweet.
All right. Thank you all for coming. This is the Denver Code Club meetup here at Kenzan. I'm Daniel Williams, and today I'm going to be talking about application advice as part of our series for Modern Microservices. Okay. There we go. All right. So first off, I have to go through some of the marketing stuff about Kenzan. We are Kenzan. We do stuff in the cloud. I'm sure our marketing person is going to bite my head off for this, but we do all kinds of stuff in the cloud. We tend to focus on media, but we're not constrained specifically to media, Netflixy type things, though we do use a lot of Netflix open source stack. So if you want more information, this slide is in the deck that's in the GitHub, github.com/KenzanLabs/Modern Microservices. No spaces anywhere in it. So the whole series is focusing on microservices and building out microservices architecture. The four kind of big areas are platform and infrastructure, continuous delivery, continuous integration, and applications. Today we're going to talk about applications. So here's the diagram I keep showing that kind of shows how they all fit together. We're going to focus up here in the application space. All right, so one of the things I mentioned in the intro, and I'm going to be poking into basically with this entire slide deck today, is a number of the points in the 12-factor app. Not specifically because I think the 12-factor app is the most amazing thing in the world, but because it makes some good points, and it's easy to just reference that when talking about it. So all the numbers up here, you'll notice they're missing a few. I'm using these numbers match the 12 factors, and so I chose these out as things I wanted to talk about. So the first one is version control. Everything has to be in version control. This really isn't a microservices specific thing. This is you do something vaguely associated with computers, put it all in version control. You do something vaguely associated with business, put it all in version control. I wish more people knew this, but everything goes in version control. Things that we specifically use when it comes to microservices is, source code. So that's like your Python code, your Node.js code, all that kind of stuff. Configs. This is a big one. A lot of people don't think about this. Put your configs in source code. Whether it's YAML files that your application loads directly, or whether it's chunks of JSON that you go stick into your service discovery to pass it in. Put all of your configuration in version control of some sort, because that way, whenever you make a change, you can see what change you made, and then if it all burns down and you wake up the next morning and you don't know why your production's down, you can see what change you made in the config, and you can roll it back. So configs are a huge one. I've seen this time and time and time again. People don't version control their configs, and then they're just panicking. What did I change yesterday? What did I change yesterday? And then 5, 10 different config revisions later, they're finally kind of sort of back to where they are. Artifacts. Artifacts is one of those nebulous terms, but artifacts are what comes out of your build process, right? So a lot of what we'll be using here, my examples, this is the Docker images. A lot of times artifacts are your libraries that you include in your software when you put it in your Docker image. But Docker images themselves are artifacts. Any libraries you built are artifacts. Any libraries you got off the internet from that one guy out in Russia that you're like, I don't know if I should be using this library, but it's the only one that does that weird PDF conversion. All right, we're going to go ahead and use that's an artifact. Put it in your version control, your artifact version control, hash it, and make sure you use it everywhere you go. So that way, if anything changes, you're going to know. It's going to stand out like a sore thumb. Libraries are big on this one. I've seen time and time and time again where you go to build your next version of your app, it pulls in a new library from pip or from NuGet or from whatever artifact repository that you're using out on the internet, and all of a sudden there's a new minor version, and and it's got some weird thing that broke whatever one little tiny piece you're using, and now your entire application burned down, and now you have to figure out how to go force that library backwards so you can get your application to build and run. And you usually find out about that in production. So, artifacts. And the last one is documentation. This is one that amazes me that more people don't have in version control also. Really, in my opinion, your documentation should be written alongside, if not at the same time and before your code, but we know that never happens in the real world. So when you're writing your documentation, version control it, right? There's tons of systems for documentation generation. I personally know LaTeX, right? So I know nobody here, unless you're a physicist, knows what LaTeX is, much less. Okay, we do have some people that know what LaTeX is.
Just never used it.
Oh, I've used it. I've written like 500-page, reports and books and stuff in the thing. It is the most amazing thing. So when I was in my electrical engineering classes, one of the professors had us write a report. It was only like a 5 or 6 page report, but we had to use the IEEE format. And half the points of the paper were making sure we didn't get anything wrong on the IEEE format. And I don't know if you've ever seen it, but it's that like 2-column, and the pictures have to fit in the column, and all your references are at the bottom. It's a very, very specific, very, very detailed format. He made us write it, and basically everybody in the class had 2 options. You could use LaTeX, or you could use Microsoft Word. Everybody who wrote it in Microsoft Word missed like half of the points, because there's all kinds of weird little formatting errors, even using the IEEE templates. Everybody who wrote it in LaTeX missed 1 point, because there was a bug in the IEEE supplied style.
Template sheet or style sheet.
Yeah, they don't call it style sheet, they call it document class. That's what it is. But in the LaTeX supplied by IEEE, there was a bug in there, and so everybody missed 1 point on the LaTeX side. So being around a bunch of physics kids in college, I learned LaTeX early on. So, but LaTeX, Python has Sphinx. Doxygen is a huge one, right? Doxygen you can write on everything. Everything can be put in a Doxygen format. I personally recommend using a documentation generation system like those. But even if you don't use those, even if you just use Word docs, put it in version control. DocX is XML under the hood. So when they switched from doc to docx, it became XML under the hood. So you can put it in Git, and Git actually does pretty well with it. But put it all in version control, so that way when somebody comes and they're like, oh, this one thing, you took it out of your documentation, you can go back and be like, no, it was never in there, or, oh yeah, we did take it out here, let me just copy and paste it back in from my history or whatever. Makes documentation fix-ups so much easier, but literally everything goes in version control. If you have any questions, just go ahead and yell them at me. All right, so jumping to point number 3, configuration. The 12-factor app says configuration should come from outside of the app. I've expanded on this a little bit. First and foremost, configuration should be simple. I see way too many applications where you go into the config file and it's like half a megabyte of comments explaining the 10,000 config options they have. You're never going to know what all of those are or have a chance to test them, right? You don't need 37 different timeouts. Stick to like 2. You have your connection timeout and you have your request timeout. And if that doesn't work for you, then you should probably do some multiplier of one of those 2 in whatever else you need if you need more specifics. Or just hard code it, because it's probably going to be a very specific timeout anyway. Configurations need to be simple. These computing systems that we're building, right? Distributed microservice-based cloud architectures where you've got hundreds of little microservices running around, and they've all got 10 copies of themselves, right? If you look at Netflix, they've got over 1,000 different microservices in their system, distinct microservices, and then they've got tens to hundreds of each of those in their platform. No one person can keep that in their head. Hell, we're getting to the point where no 100-person engineering team can keep that all in their heads collectively if everybody didn't overlap. So the complexity is up there. We need to start taking some of that complexity back out. Keep our configuration simple. 9 times out of 10, the configuration option is really not needed, or it can be set to a default value and forgotten about. And if somebody really, really, really needs that one super fine tweak, they can fork it, they can tweak the code, and they can deploy it out of their own GitHub. This is the other one that they actually talk about. The configuration should come from outside the app. A lot of these points kind of all work together on different aspects of basically coming to the idea that your app is an artifact and you should be able to deploy it anywhere, anytime. And so this is a big one, right? If you hard code your database name into your Docker container, that Docker container only runs in that environment. Or you have to specifically build your environments around that Docker container. If you supply your database name, your database host name in through an external, I like to use environment variables. A lot of people like to use service discovery between different different services. But for database, they usually use environment variables because they're easy and they work everywhere. But if you pass that in through like an environment variable from your Kubernetes manifest, or from Spinnaker, or from your Docker command line, or wherever you're running it, then no matter what environment you're in, you can specify, hey, you container, your database is over there. Go talk to that one. Oh, the one that's running right next to you, actually I want you to talk to that database over there because it's got different testing. So you can do things like that. And so it's very important that any app you make, all your configuration comes from outside the app. The way I usually do this is I usually specify like basic database things, database connections, message queue connections, things like that in the environmentals. And then any actual operational configuration, like user databases or user-specific settings or time formats or anything like that will come out of a database or a configuration manager like IDO, or it'll be passed along with the chunk of data that's being worked on through the message queue into the data database. So, go ahead.
With the exception of credentials, do you find a need to preserve the information to be stored in environment variables, just like you find a need to preserve traditional artifacts?
Yes.
So what's your process for doing it?
So, like, what I'll show you a little bit later today, a little bit later
If
tonight.
you're using Kubernetes, you just map all of your deployments into configuration management, or
Right. So I've got the way I did it in the last place, and the way I've done it on the stuff I'm going to show you today, which is just example stuff. I have a manifest file that's in Git, and in there I have this manifest file is for this environment, and it's all pretty much the same, right? It points to Docker container. It has some names in it, but then it has environmental variable, name value, name value, name value,
Sure.
just right there in the manifest. The manifest is in Git. So that way, if I ever need to go redeploy that application, I just, can take, hey, Kubernetes, go load that file up and recreate yourself. A lot of things like Spinnaker, Spinnaker is a deployment tool we'll see in a few sessions. A lot of that stuff is saved internally inside of the Spinnaker databases, but those Spinnaker pipelines are coded in JSON, so you can save, generally what you do is you take and you go create your pipeline and save it out as JSON, so you can push the JSON back in if you need to recreate the pipeline. And the environmental variables are configured in there, either as hard-coded values for that environment, or as like expressions that go pull information out of your build or out of your source code. A lot of times, like when you're going through the deployment systems like Spinnaker, you'll be 2 or 3 layers deep in getting to that value when it's in version control, but it's still there somewhere. You know what it is. Spinnaker stores all that stuff and has execution versions and all that kind of thing. But like today, it's just written right in the manifest, and that manifest is just a YAML file stuck in GitHub. So, but yes, version control all of these values, right? Service discovery, so like Eureka or IDO, when those values go in there, there's certain things that won't be version controlled, like, hey, that service started up and there's those 5 nodes of it, and I need to go talk to the load balancer for those 5 nodes, right? That's all generated by the environment, and so that's right. That's all logged. That's all. It's generated, so it should be able to regenerate. It's ephemeral data. But if you have any configuration like timeout lengths or anything like that, before you go stick it into Eureka or stick it into IDO, you put it in Git. I like it. I've dealt with Subversion, RCS, and CVS, and paper with signatures on it. I've dealt with all kinds of version controls. Git is nice.
And IDO is actually just a wrap around Git.
Right, it's a wrapper around Git specifically to focus on config changes, application config changes. I'm not going to go into IDO too much here, but it is something that you can look at. It's EIDDO. But it's an interesting service, and our clients use it. And when it works great. When it doesn't, just like everything else, debugging is a nightmare. So,
I'm sorry, can you spell that again?
EIDDO. So again, jumping numbers. A couple of these other numbers, like I think number 5 was talking about, it's like code, build, run. I'm going to leave some of those for continuous integration, continuous delivery stuff. So we're going to jump up here to 6, processes. Basically it says, in the 12-factor app thing, processes should be stateless. And that's true, yes. I mean, not counting your data stores where you actually store your data, all of your actual application that's doing the business logic, they should be stateless threads. Everything that's in process data should eventually come out of or go into some sort of either queue or database. Not counting the actual client request coming into your web server, but your web server should push into a queue. That queue should then feed back into a background service or a whole lot of background services, and then eventually make it into databases in a data layer. But you shouldn't have any business logic in those data layers. All your business logic should be wrapped in applications that are stateless. They don't hold any data, even to the point where they don't generally hold any data from request to request. All your control data should come from the environment. And I say C3 because we just said that, right? This is configuration, control data. It should come from the environment somewhere, like I was just talking about. But the idea here is you want to be able to spin this up without any worry about it having to go generate a bunch of state or collect a bunch of state, and then you shut it down. You don't want to have a bunch of state that it has to deal with, right? It should just be stateless. Press the button, it goes away. This is one of the reasons why you want it to be stateless, concurrency. Everything you do in a microservices architecture should be parallelizable. If it's not, you can't scale. Simple as that. Which is part of the reason we want to take people out of that workflow. So if you ever have a point where somebody has to touch it, get rid of that. But everything should be parallelizable. You want, I'm running with 3 nodes of that application, or three instances of that application, and you get broadsided by, you get slash dotted, I think was the term from like 5 years ago. You get slash dotted, and now you have a bazillion requests happening. You want to be able to make 15 more copies of that, work your load, and then knock it back down to 3, right? It's the whole AWS auto-scaling group. If it's not parallelizable, if it's not something that can run completely in parallel without like a shared state or without an independent state, then your ASG is just going to burn down as soon as it tries to scale. So this is stating it a little different way. It should be able to make more copies and then make less copies and work just fine. This goes back to number 6, disposability. You want quick startup, you want quick shutdown. One of the biggest ways you get that is being stateless, right? If you have no state to start up with, to gather when you start up, and you have no state to save somewhere when you shut down, you're going to be much easier to be disposable, right? Take statelessness and parallelizable, put them together, and you get disposability, right? If you got no global state, you don't have to worry about it. This is a key one in the cloud. Things go down and things go down hard, and it happens all the time. Expect it to happen. Design your systems, design your applications to go down hard and recover gracefully. There's time and time and time again, you'll have 20 instances running in an ASG, or you'll have 15 pods running in Kubernetes, and AWS or Google will politely come up and they're like, we're doing maintenance on this rack today. Boom! All of a sudden, anything running on that rack is toast, right? And if it's 2 instances of your ASG happen to be on that rack that day, guess what? They're gone. The ASG is going to turn them on somewhere else, which is what you want it to do. But your application has to be ready for that. All these other things lead up. These all go hand in hand. So make sure that if your application is terminated abruptly, if somebody goes in and hits the big Control C on the entire rack, when you turn it back on, it's going to work fine. Databases are a little different because databases generally don't do that, but databases you have to, wear with cotton gloves. Those like nice white gloves that you see in the labs. But we're not talking about databases today, we're talking applications. Oops, I think I got an extra slide in here. Yeah, I had an extra slide in there last time. All right. Logs. Literally log all the things. If you don't log, you're blind, right? These systems, these microservices, these applications, they're designed in such a way, and these systems are designed in such a way, and these frameworks are designed in such a way that if you could even log in and get to a console next to where the application is running and be able to run some things like PS or top or anything like that, it is incredibly challenging. And I know Kubernetes, they actively prevent you from doing it, right? It's for security. But you really shouldn't be doing that. So that your way to get visibility in all these things, because you're not going to be able to like hook a debugger into your Kubernetes cluster like you could with your embedded application, right? I used to do embedded dev.
Cube Squash was specifically built to hook debuggers into applications that are deployed on Kubernetes.
Can you say that louder?
Cube Squash is a tool that's specifically meant for hooking in things like GDB or other traditional debuggers into applications that are running in containers on Kubernetes.
Is that sidecar injection?
I don't think it uses sidecar injection. I think it just uses traditional C group namespace.
My guess is it would use something like it would
I
run
think it's just using the same process namespace, and because it's in the same process namespace and you give it capsys admin, then it's able to directly hook up to the process and
That's
just like
some-
GDB would.
Right, that's
do
something
it
to look
with
into,
traditional, like,
but-
true proc mem.
that sounds incredibly painful, especially for trying to run it like on Google GCP's Kubernetes. But I also was never a big fan of a debugger, even when I was writing embedded firmware and I had my JTAG plugged right into the board. I tried to avoid the debugger at all costs. I like logging. But again, so unless you use something like Cube Squash, which sounds incredibly painful, I hope to never have to debug that application. Which apparently, Cube Squash, as he said, is GDB into running containers on Kubernetes.
And it's not just GDB. There's a Python debugger. There's a JVM debugger as well.
Okay, debuggers into containers running on Kubernetes. That sounds incredibly painful, and I hope I never have to fire one of those up. But if I do, now I know. But in the meantime, for all of us mere mortals, we're going to stick with logging as our view into what's going on inside the container. One of the things I see a lot of problems with is people aren't very good at choosing the correct log level. So, like, one of the ones I've been dealing with a client of ours. No, they have a logging thing set up to take all of their requests to an Elasticsearch cluster, a very large Elasticsearch cluster, and all of the responses from said Elasticsearch cluster, and sideline them all into Greylog. Greylog being a logging cluster, kind of like Elk or any of the other ones. But so basically, we have these requests and these massive response sets that come back, and they're trying to sideline this into the log server in production. So like 8,000 requests per second to the tune of half a meg per request. At least, it's over the 32K limit of log server. So we're regularly throwing thousands of messages away per second because they're so big, and they're sidelining them in because they forgot, I probably should have that one called debug and not have debug turned on in production. So make sure you put it on the right log level. Passwords and things shouldn't be in logs. usernames are fine. If you're going to do big chunks of data or big stack traces, make sure it's coming out at the debug level. Make sure you don't have debug turned on. Also, when you do all this, use a logging library. One of the things that I see a lot, usually more in like old C and C++ code, is people will kind of make their own half-built logging library because they weren't trying to make it more efficient, but they end up doing things like every time they go call their log function, they do this big if-else statement to try and figure out if they need to log that time or not, and it becomes very inefficient, where most logging libraries have been tuned to basically shortcut. Say if you're logging at info level and you have a bunch of debug statements, they basically shortcut the calls. So the call starts and immediately comes back because it's a debug, it shouldn't happen, before it even tries to go process variables or do any kind of string formatting or anything like that. So if at all possible, use a logging library. I mean, sometimes your logging library is literally just a print statement, right? Some of the really simple Node.js stuff we'll see a little bit later on, it's just a couple of print statements right now because the application didn't need any more than that. We probably would have doubled the number of lines of the application just by adding a logging library, but 9 times out of 10, you want to use a logging library because you don't have to think about it and it shortcuts things and helps maintain performance. Also, use a log collection and aggregation service. This is one a lot of people don't do, and it's a royal pain to go chase logs on different instances if you're running instances. You put it into Kubernetes with 20 or 30 times, and now you're chasing logs for containers on the actual worker nodes, and it gets really ugly. So use some sort of aggregation service. I mentioned Graylog a little bit earlier. Graylog's a pretty good one. It's a server service that then stores everything in Elasticsearch for quick reference. I've used elk stacks before, so Elasticsearch, Logstash, Kibana. Basically, Logstash reads your local text logs, pumps them into Elasticsearch, and Kibana is a dashboard to search it. There's a number of online, like software as a service type log systems. They get a little pricey, but if you just need a small thing or you need something yesterday, they're great options. Google Cloud is actually, its stack driver is really nice because it's all tied into their Kubernetes cluster. So you can literally just dump, you can print to standard out. So like I just have my logger configured to output to the standard out, and then it comes out of the console, Kubernetes grabs it and then passes it off. Google's version of Kubernetes grabs it, passes it off to Stackdriver, which is Google's big logging collector. And so you can go in there and you can hit, oh, this pod, give me the logs, and it takes you over to Stackdriver, and then it's right there. And then you can tweak the query to get all the pods for that service, all the pods for that deployment. That's the right word for Kubernetes, deployment. But you can do things like that where, you know, if you have that logging thing, you can look at what all of your application nodes are doing at the same time, and you can see if it's something that's like bouncing around, or if it's intermittent, or if they all have the same issue, and then it comes back, which means it's probably something, you know, farther back in the system than them, like a intermittent database connection or network connection, or a bad service that they're all relying on. So use some sort of collection and aggregation service. There's lots of them out there. Use one. All right. We're going to take a couple minutes of break because I just need to grab some water. But these are the two GitHubs we're going to walk through here in the next few minutes. I'm going to point out some of the things that I've done and just kind of example code it. They're both fairly short, so it won't be too long. And then if you have any questions or you want to talk any more about some of these things or some similar microservice-y things, we can jump into that after a quick walkthrough. If anybody needs more pizza or beer, it's in there. whatever, most people are bad. All right, so you were asking about the manifest file. So this is the manifest file I used to fire up one of the applications, the Python one, that I smashed together today in Kubernetes. So if you look here, the first part just fires up a Redis server using the standard Redis server and its service. But then this is the part right here where you can see I'm passing in environmental variables. So listener port to 8080 Redis server, go use that one, and then the port. So that's actually in version control. So now if I ever need to go update, I can copy and paste it in. I can tell Kubernetes to go pull this file, or I could have something that's a little more automated, grab this file and push it into Kubernetes. But it's here, it's version control. So this is actually the last big production system I did for Kubernetes, which was at the end of last year. This is how we specified all of our configuration for our actual environment. It was before I'd learned about Spinnaker, so I was writing all these manifests by hand, but we built everything like this. And one of the biggest reasons I chose to do it this way for the core configuration was so I could develop on Docker on my workstation. Right? I had basically a big Linux box sitting next to my Windows workstation, and I had Docker running on that Linux box, and so I could run a Redis server, and then in Docker I could just pass into the command line environmental variables. A year ago, I don't know if Docker has it now, I haven't looked, but a year ago Docker could not handle the config maps that Kubernetes had. So I couldn't really use config maps in Kubernetes if I was developing in just straight Docker on my workstation. And I didn't want to take the time to go try and figure out how to set up an entire Kubernetes cluster on the box next to my computer or Minikube or any of that kind of stuff. Docker was there and running, so I used environmental variables, but they were all version controlled. So, in here, so this is also something else that you want to have in version control, and you can see my application is very complicated. It has one requirement beyond base Python, but requirements for your application, get those into your version control. Don't let your build system just magically have them, right? This is a wonderful thing in Python with pip. So that way, every time you go rebuild that thing, you have your requirements here. And yeah, you have to run a install the requirements command, but you automate that as part of your build script and you're fine. But now, anytime anybody builds this, they know exactly which versions they have to have for this application to run. A lot of application and a lot of application frameworks and a lot of build environments don't do this. And it seems like one of those, once you start doing it, it just seems like one of those no-brainer, the duh moments. But even with a lot of the C stuff I wrote and worked on long before I got into the Python, nobody did this. And then all of a sudden, or they would do it in, oh, you have to go install these versions by hand of all these dependencies and hope you've configured them right by reading this terribly written PDF document that somebody printed off and photocopied 5 times. And that's how you get your dependencies in. It doesn't work. So that's always a good thing to have.
The requirements text file for Python, is that a pip thing? Or what's the...
It's a pip thing. So, in fact, I'll pop over here into my Docker file. So if you look here, I stuck this link in here just because this is where I just, I stole how to make this Docker file from there. But so grab the Python Docker image as the base, copy the requirements file into it, and then run pip install -r requirements. It's a Python pip thing. But basically, at this day and age, if you're installing requirements for Python and you're not using pip, it's either something super custom that you have on your machine and you haven't packaged yet, or you're just masochistic. Just about everything else comes through here. So even in that last project that I worked on last year, that production deployment, all the libraries that we could open source, we open sourced and we put in PyPy, so they'd install through pip. Anything that we couldn't put into PyPy, we built our own PyPy server in the office. So we had a Jenkins build job that would build the libraries and then put them into PyPy with all their hashes and everything else. And then our actual application just had our private stuff and our public stuff referenced in it, and it just installed it either from the public PyPy or our internal PyPy. Either way, it was all artifacts that we could test them to no end before we put them out into production. And this stuff was like, a lot of these Python packages that we were writing were installed on data loggers that talked over modems. So firmware updates didn't happen, right? They had to be tested and they had to work before the box shipped out of our office, because it was going to get installed and it was going to run for 15 or 30 years, hanging on that wall in that one place, getting a phone call once a day to push it, to have its data pulled back, and it's never going to be touched again. No updates, no nothing. A lot of them were on the internet, so we could eventually push updates, but we basically had to write these things like there was no updates, so we needed to test them. So we wanted to make sure the artifacts that we tested, the actual bit-for-bit code that we ran out in the field, was stuff that we had actually tested, and not a rebuild that might accidentally have a library change. But yeah, so something like that. I know C# has something similar to the requirements.txt. It's a lot uglier, but most of the modern languages, Java has it.
Maybe
Again.
and or Gradle.
What's that?
Maybe and or Gradle. Java has too many of these.
Yes.
Java has like 5 or 6 different build systems that all have that beyond the stuff that's built straight into Java. Python has this. C# has their. I don't remember the name of it, but it's got NuGet stuff in there. But they're also just their straight assembly requirements. But anyway, so a lot of the modern languages have this stuff. The older languages like C and C++, people have built frameworks that handle this kind of stuff. So use one of those. So just about everything short of like straight sling and assembly, which I don't recommend anybody do ever again, you're going to have something that'll do this requirement stuff. So just to burn your eyes with my incredibly quick and dirty Python. So you see here, there's not a whole lot going on. Basically, get my login, get my OS for my environmental variables, get Redis, and then the HTTP server. So this section here is pulling environmental variables, right? Those are the ones we passed in through that manifest file. I also test them out on my local workstation by passing them on the Docker line. One thing that a lot of people miss is setting defaults, setting sane defaults, right? Host names, localhost, usually a good idea. Ports, set it to whatever that service's default port is. But you always want to have a sane default when you're bringing in configuration, but bring it in from outside. So this is the serving class that serves what's going on. Here's the logger, here's where I set up the logger for this class, so I know it's going to have the name, server class, very original. It's going to have that name on every log statement that pops out, because that logger has that name on it. And then, down here, I log stuff. So this one's an info, I'm doing a GET request, but then this one down here that actually dumps the output, it's a debug statement. And then down here is just the main, and this is this is seeding the database for this example, but I've again set up some logging formats and stuff like that, and then run my web server. So it's not hard. What is it? 83 lines. I didn't even make it with all the space, the empty lines. I didn't even make it to 100. But if I do this right, bring this up. So this is what this application does. Basically, you call to the Python, it goes to the Redis database, grabs one of these cat files that's base64 encoded, and then brings it back. So pictures pop up. I mean, incredibly original, right? Yes, and this one's Dookie Cat. But it's just showing that we're hopping services and we're passing in configuration to the Redis database into the Python from that manifest file environment to say, go talk to that one. We load some data into it when the server starts, and then we pull it back up. One of the other things that's really I wanted to show about this also is if I go here to this workloads, be logged in. There we go. So then I can come down here to my pod, logs, container logs, And this is what I was saying about Stackdriver, one of the log aggregation systems. If you look here, now I have my logs from my server. So you can see here, handling GET request. This is the web servers frameworks thing. And then you have, it returns the response. It's initializing the class again, it's handling a GET request, and then it returns the response. And so now, because I have log aggregation, I can go in here and I can search and I can see what's going on with that server if it decides to go wrong. So if I were to say, go kill the Redis server, I would have an error in here that I could still access without trying to go figure out or go to the service itself and whoop, it gives me an error. I can see that right here.
In terms of best practices, you wouldn't actually couple Redis as a sidecar in your application, would you?
Redis is not coupled as a sidecar in my application. I have two separate pods, two separate deployments running one pod each.
Okay.
The Python application has configuration to say go out through.
But they are entirely separate deployments.
They're entirely separate
Okay,
deployments. I just stuck them in the same manifest file, so
Gotcha.
it's all in one file.
That,
But it's a deployment, a
that's what I
service,
was-
a deployment, and a
We use
service.
Istio generally to handle service mesh.
Okay.
Yeah,
Right. So this I just shortcut because I didn't need the Istio stuff.
that's
But yeah, they're two separate deployments. In fact, I can go back over. Well, I'll do it on the Kubernetes dashboard since it's complaining. But so
Yeah, it's only because they're in the same YAML file that I assumed they were
Right,
API objects,
right, and
those
so-
are two in the same file.
if you go look at that file, there's dash dash dash
Right.
in
They're
between
two
each of the
separate
sections.
API
So,
objects.
but yeah, so you can see here deployments. There's the Python. There's the Redis. This one talks to this one, and this one has the name and the port and all that stuff of this one into it via environmentals because that's what was easy to get done today.
Sure.
But yeah, they're two fully separate deployments, and this one knows to talk to that one because I told it. If I had a completely different Redis server, I could put that in the environment for this one and have it go talk to, Elastic Cache on AWS if I was dumb enough to expose that straight to the internet. I could do that, and it would work just fine. So I just did this because it was quick and easy. But yeah, they're two separate deployments.
So, best practices. When you talk about labels, I see that you've got like a tier label. Is that something that you would do in a normal production app, or?
These tier labels came from the examples that Craig and I were copying today when we were building this stuff up real quick. Tier isn't a bad label to have, but you got to make sure whatever value you stick into it. So we have a front end and a back end, right? So normally, I personally wouldn't do that. I would have them like this would have like a web server tier. You would have a database tier. Like I would have like a web server tier, a database tier, and even if I had multiple types of web services, multiple web service, microservices, you'd have to lay out the tiers however your application sees fit. I've worked on applications that are like 5 layers deep, and I've worked on applications that are 2.
So you guys use labels then a lot in your applications?
Absolutely.
Yeah, and I think the standard, we kind of just almost worked out right, is application, environment, and then the part of the stack that is, like we say, front, middle, back, dev, scratch, test,
Right.
prod, non-prod, you could have,
Yeah, we've got
make it flexible for the future.
We've pretty much got 5 different environment tier or labels that we use on just about everything, and everything pretty much gets that. There's Scratch, which is we're playing around, man. It's the Wild West. We then have Dev, we have Test, we have Production, and then we have DevOps is one that we'll usually put on a lot of things that are like when we're running Spinnaker. Spinnaker we don't want running in the production environment or the dev environment because it deploys to both. So Spinnaker runs in DevOps. It's kind of off to the side. You could call it operations. We just happen to call it DevOps because it's shorter, but it's basically like all of the stuff that's making the rest of the environments work area.
It's the bastion account almost, right?
No, it's more like the infrastructure account.
Right, but a bastion is just going to log the hell out and make sure it's secure. The DevOps account is secure.
Right, you keep it logged down, and you have to double bastion to get into it, and stuff like that. But it's more of the infrastructure account. You can call it infrastructure, you can call it ops. We just happen to call it DevOps because it's short. That's what somebody started doing years ago. But yeah, so every single thing that gets deployed gets one of those on here.
So they all get an environment then?
They all get which environment they're running in as a label. They all get On some of our stuff, like especially when we're using Spinnaker to deploy them, Spinnaker will put like 10 things on there, right?
Sure.
What's your cloud app? What's your environment? What's your your ASG, your server group name? What's your
Version stacks.
your versions, your launch configs? You could put 15 or 20 different labels here. Definitely label things. The more information you have that you can look at, the better, right? I would say that there's never too many labels, but there absolutely will be a point where it's too many labels. But this was what came in the example, so that's what I used. But definitely label things. So.
Especially once you hook it up to something like Prometheus, having
Right.
a lot of complex labels, like just having a lot of richness in your
Well, and
labels
that's
gives you a lot of ability to just slice your data later.
if you look up here, all the logging stuff, you search on it based on the label of where it came from.
You can do aggregations based on this.
Right, all your logging aggregations and stuff like that. So right now I have it specifically in this pod ID, but I could take this pod ID off and all these other labels, the names and stuff, all these other labels that are on those resources will then roll up. So it's not going to change anything here because I only have the one pod, but say I had 10 pods, I could take the pod ID off and just use the rest, and then I would have all the logs from all 10 pods together. So labels are good.
How do you, we don't have to talk about it here, but I would love to understand better how you pull the data in for the labels that get attached to a container into an application to say add to your logging and stuff like that.
It really depends on what you're using. So like this, I do it like this. Google Magic, Google Magic, Google
Got it.
Magic.
Yeah,
But-
usually with your application code, you usually would not pull the Kubernetes API to get your labels. You'd rather have whatever's collecting all your logs and shipping it off to your logging framework, that would annotate those labels on. So if you use Kubernetes, then if you're in the cloud, use something like CloudWatch, but otherwise use something like Fluentd or FileBeats now can also communicate with the Kubernetes API, and it'll just grab the annotations and labels off of the containers that are supplying those logs. And
A
then
lot of things like
decorate the logs with that.
so Google has a bunch of stuff built into its Kubernetes to grab all that stuff for you, so you don't even really have to tickle the API. I know Istio has a bunch of stuff in there to, since it's already a plugin in Kubernetes, it can grab all that information on the fly and stick it on your logs, on a bunch of your traces and all that kind of stuff. It sticks all that stuff on there, so it really depends on what you're using to do the logging. And if you're using Kubernetes, get something that can work with Kubernetes and do that if you're on a version of Kubernetes that can't just do it inherently. There's a lot of other places where we do things like the Graylog I talked about earlier, right? So there are a lot of, this is more EC2 instances than containers, but you'll have the Graylog collector running on your EC2 instance. And so what it will do is we'll pass a lot of that environment data, all those labels, they basically get stuck as environment variables into the user data. So then when Graylog collector runs inside, it can say, basically it goes and it loads the user data up as it's starting, and then it has all those environmental variables, so you can grab them and just put all those labels on everything it ships out. So it's another way you can do it. I've seen some custom logging things where basically the logs come in with an IP address, and then the logging system then goes back and pulls, say, AWS or Google every so often and says, basically, hey, I got this IP address. Give me all the user data, or give me all the tags for the instance that has this IP address. And then it gets it that way, and the logging system does it. The log aggregator does it behind the scenes. So there's a bunch of different ways to do it, but get as close to whatever deployment system you're using. Get as close to that as you can. So like I say, in this case, all of this is done by Google Magic. They built it into their Kubernetes. When we're using Graylog, we pass all that data in as close to the collector as we can get it, so it can just grab it and pass it on. So basically, we put all those values in the user data, and the user data gets sucked inside the instance, and then picked up and pushed on with the log entries. Also, like I say, Istio and some of the service meshes that have some of that extra logging and tracing functionality in there for all the requests, they can provide all that information. They can attach it all to the requests on their way back to your log aggregator. So, any questions on the Python application? The logging, the environmental variables being passed in, things like that. All right, I'm going to poke around the JavaScript. I didn't write it, so I don't know it as well. So here is, I believe it's this one. Here's the manifest, very similar. For the API, no environmental variables here because it just is what it is. When you see the code, the manifest is as long as the code, pretty much. But yeah, so see, it gets from the environment, the port, otherwise it uses 5001, and then it runs. What this does is basically there's a list of framework names. In fact, I can just show you real quick. So this is what it does. Basically, the backend API is returning these names, and then there's a front-end proxy, and then some UI stuff that's doing the fancy wheel. I'm not this fancy. This is all Craig stuff. He likes doing it. I can't figure that stuff out. But yeah, so again, this is just another application showing the going to one, proxying over to the other. So this one pulls out JavaScript. The JavaScript then goes back to the main microservice that handed the JavaScript out, and then that one proxies back to a different container in Kubernetes. If we go here, so we misnamed it, but this is the UI. So this is the Node.js that hands out the UI, but then it also proxies the call back to the API, which then returns the names. So it's another one of these where here we pass in environmental variables to get back to here. We're doing the networking in there. And again, because Kubernetes in this case handles a lot of the logging, one of the things I wanted to point out with this application is, where is it? Right here, console.log. This was more than enough logging with our super high power, logging library, console.log in Node.js, because all we're doing is this very simple little application, and this was enough to just put it out, and then Kubernetes picks it up through the Google magic, sends it off to Stackdriver, and then you can go look it up and see what's going on. So it's a really, really simple thing. And then here's the actual, I believe this is the actual, yeah, here's the list of frameworks. But this is also one kind of while this list is compiled into this application, which is where it should be, it's separated out into a separate data file, which is also kind of a good thing. Well, it's a good thing you should do with your application. Don't do it with everything. I've seen applications where people will go in and take every string and obfuscate it 5 hops or whatever to try and make it where, oh, I might use that string a second time somewhere in the application, so I've given it 5 different names through different function calls. That's way too much. But if you have a big list of things, especially if, there's a good chance if this were to be a production application, there's a good chance we'd come back and we want to add frameworks into that because there seems to be a Node.js framework popping up every other week. We'd be updating this list, so we put this in a JSON file, and the application loads it up and then starts returning values out of it. So while it's still compiled in, it's still part of the application, it's part of the artifact, it's still separated out enough that we can go quickly change it and work on it. So it's a judgment on whether its configuration needs to come outside or it's more like just data and it can be in the application.
For something like that, how do you make the determination whether this should be an artifact that's stored within your repository or whether it should just be database information that you have some access through your UI to hit an API endpoint to add and remove frameworks and just store it in your database?
So the two judgments that I personally make, and this is entirely opinion, which means it's probably full of crap. Number one, if it's going to be changing constantly, it's going to be changing constantly. You're constantly updating it, right? Put it in a database. If users are constantly updating it, put it in a database. The other thing is if it's something that's ephemeral data, it's generated data, it needs to come from some other repository, usually something else puts it in a database and you get it out of the database. So if it's generated or if it's something that's going to be updated constantly. When I say constantly, faster, like an order of magnitude faster than your deployment schedule. that's kind of the point where I put in the database. A lot of things like posts on WordPress, for a terrible example. Those are things people enter. You never know what they're going to be. They need to go in a database. You know, people are going to be editing them all the time, things like that. That kind of stuff goes in the database. But things like this, where you have a list of names, that chances are, as long as you didn't misspell it, you're not going to be removing them, or you're not going to be updating them. You might be adding to the list, but you can do that when the next rollout happens. This would go into a list that gets packaged with the actual application, in my mind. Far too often I see people try and put a bunch of these, I don't want to call them constants, but they're like semi-constants. They put these in databases, and so you end up with databases that have like 3 data tables and 300 semi-constant tables that are touched once every 6 months. I actually worked on an application where somebody had put the list of states in a database table. That was a huge one to come back and put like this. Pretty sure the US is not going to change the number of states very often, right? We've been stuck at 50 for how many years? Even, you know, if you add in the 4 outlying territories, 4 or 5 outlying territories, like, we've been pretty steady state on those, right? So that's a great one for one of these lists, but because you don't want to just have a big chunk of list in your code, but at the same time, it has no business being in a database. It's just wasting space and wasting time in a database. Make sense? All right, I'm going to jump back over to the UI. So again, looking at the manifest, just like we saw before, on this one, you know, API URL, API port goes in there. There are ways to actually look up this kind of information straight out of Kubernetes, but just for the examples today, we use environmental variables because I like them. Now this is the part where it's a little deeper than I know to play with. Right, so you can see in here, this is a little more complicated. It goes to the framework API. Again, console logging, because it's not a really complicated application, it doesn't need much more. But I do know this application is actually going to get, this UI one is going to get a proper logging library that will, again, push out to the console because it's in Google Kubernetes, but it will get a proper logging library when Craig goes and puts the circuit breaker stuff in, which I know he's doing a talk at another meetup. I think it's a meetup, early October, and then he's also most likely going to either do a talk at the Denver Code Club meetup here, or he's going to like add on as a small segment about this circuit breaker stuff. So keep an eye on this repo and keep an eye on our meetup, and I'll have Craig put a post out about it so you can find out where he's talking about it. So he's going to be boosting this up, but again, he's going to start putting things like logging in there, but he did put the environmental variable stuff in here. So you can see here, pulls in from environmental variable things. So you can see, yeah, I think there, and then, I don't remember where the other one was, but basically pulls in from environmental variables to get that config data in. So we can run this anywhere. We ran it on his local laptop, we ran it in Kubernetes with 0 changes to the application once the environmental variables were let us pass things in. And that's one of the big things. In fact, it was the same, he built it on his workstation with Docker, ran it there, tested it, it worked, he pushed it to Docker Hub, and then we pulled it into Kubernetes from Docker Hub. So it's actually the same, what's running in Kubernetes now that you just saw is the same thing that was running on his laptop this morning. And that's why we want version control, we want artifact control, and that's why we want to make sure configuration comes in from the outside world. All right, I think that's the end of what I have. So we're going to go back to cat or not and look at pictures of cats. Any other questions? There.
So this may be more related to the infrastructure of the platform that you're running on.
this seems kind of like it could be also related to logging. So I'm thinking about like how you would approach trying to diagnose, like, let's say performance issues in some part of your back-end response. And like, do you go to the length of logging like times of like important sections of your back-end process, like specifically? Well,
Every log statement gets a time, at least down to the millisecond.
so you just have to make sure that you're logging at least around the important sections.
Which is why it's important to use the logging library, right? So
Right.
you should be logging your response time for everything you do, and that should be and then how you can trace it.
Right.
If you need
So
more context than that, open tracing is probably a good way to go.
Open tracing.
Yeah, so open tracing is essentially decorating all of your, any of your function calls or any system calls, or if you use something like Istio, then you
Right.
get some like built-in tracing, which is essentially like when you make a call out to a different system, it has a context ID, it passes that context ID throughout all of the different calls, whether it's locally within a isolated system or if it's distributed, it just continually passes that context ID.
Right.
And by having that context ID, you pass it all off into something that essentially gets back like Cassandra or Elasticsearch.
Right.
And then when you search by that context ID, you see like where did I spend time? Did I spend time in my SQL call? Did I spend time in a Redis call? Did I spend time in this specific Java function call?
Yeah.
In a regex match or whatever?
Gotcha.
right. So open tracing is a big one, but basically tracing is just advanced logging. Like he's saying, you put context values that they can get passed around through all the calls and everything. What we would usually do on a lot of our applications, because we didn't want to bring in the overhead of all the tracing infrastructure, because you have to, like you said, you have to set up a big Elasticsearch or Cassandra cluster to hold all of that tracing information. We would have ways of basically taking like IP port number and session value, and then putting them together either as one big number or as a hash value that we would put on all of our log lines. And the logging libraries help do that. So you could say, all right, I'm instantiating this class for this, like I'm instantiating this session, go add this to all the log lines for this session. And then so it'll add in, you can see here, this is Google, but then here is actually coming out of the log library. So you have your date, your level, and then you could put another value in here before the actual function call here that says, here's a session number for the tracing type stuff. So that's a cheaper way to do it. You can do it just straight in the logging library. Or if you've got a really big application or you're doing a whole lot, definitely use tracing. A lot of the platform stuff like Istio has a lot of that request tracing, the cross-network tracing built into it. So it'll pick up those values and pass them along. Most of the log aggregation systems will be able to extract those values out. So even if you just kind of cram your own value together and stick it into logs, as long as you have some sort of delimiter, like I have the colon here, a lot of people use spaces or dashes. As long as you have some regular delimiter, you can grab that value out in like Elasticsearch. It'll grab that value out, and then when you go to a Kibana dashboard or a Graylog dashboard, you can search on that value and then filter a bunch of stuff out. That's what all of this stuff is doing. So it's part of the infrastructure and it's part of your application. It goes in both. The biggest single most helpful thing for me chasing performance down has been making sure you're using a log library that timestamps everything. I found servers that like have clocks 5 minutes off, which is causing, at the top of the hour, it'll cause weird SSL issues or just weird things like that. And it's been timestamps here. Oh, this session, and the session jumped back in time 5 minutes. Oh, okay. Something's got a bad clock. Let's go resettle the clocks. Also, you can see, 065, 65 milliseconds, 500 milliseconds. You can see there was, 450 milliseconds right there. Yeah. In the time it took from the get response to initializing the next one. So that's between two responses. But like here, you can see 3 milliseconds from initializing the class to starting the get call, starting to handle the get call.
I guess you just have to be careful to make sure you log something at some level.
Right.
Between like each distinct like step that may potentially be a performance issue. Because let's say that you were doing like 3 steps in one function, like knowing that the start of A and the end of C took a second isn't very helpful. But knowing where A, B, or C.
Right. So what I tend to do personally, I tend to put an info call at the top of every function. So like this function starting, and then maybe some values that'll help me in production, make sure that things aren't going sideways. But then throughout the rest of the function, I'll have debug statements all over the place. And then if I really need to make sure my logs are small, I can go to warning, which will then tell me nothing what's going on, but then I can kick info back on, at least see kind of stepwise what I'm doing.
Right.
The other thing is a lot of the log aggregation systems have ways to like keep errors and warnings for 6 months, roll off info after 3 months, and roll off debug after 3 days. So you can roll off your different levels at different rates like that. Even I think syslog, base old syslog will do that because you can put it in separate files, and then you log rotate your files on different schedules. And so that way you can then have all of that, your different data levels, but then make sure you're not filling up your hard drive with stacks of info when you only need a month of info, but you want to keep your errors and your warnings longer term to see when things really hit the fan. So it's hopefully that helped answer your question, but it's also one of those like really complex things about what are you doing, where are you doing it, what do you need, what are your requirements, and you start getting into different rabbit holes. Any other questions?
One thing I would throw out to that as well is don't be afraid to do things like port forwarding. And so like Kubernetes has port forwarding. That when they talked about the debugger hooking that up, you can absolutely use a lot of these tools to be able to access the components if you have to do like your profile this particular way. Why is this app behaving badly? So there are tooling out there, and they're fairly easily documented.
So part of the container, or the circuit breakers talk that Craig's going to do coming up, one of the things that's going to happen in there, we didn't do it for this because it wasn't key on this, but his UI pod is going to have a Datadog client sidecar that connects via port into the other container and pulls a bunch of metrics data out that does a lot of that profiling stuff, and then the Datadog client, he's probably going to be running a local client just to demo it, but in production, that client would then push that metrics data up to a big aggregation facility. And so it's very much performance data, very tracing type data. But yeah, it connects in through a second port on the container, and so it's 2 containers inside of one pod. This one can connect to that one, but then you can't connect that port externally because the only one that's pushed through is your actual, in this case, HTTP port. So that's the whole sidecar thing. You either run them together on an instance, or you run 2 containers inside of one pod, and then you can connect via port into your application. But you have to build that metrics facility into your application. So there's some things like that you have to build in your application to get that extra thing. 9 times out of 10, until you hit like really big sized applications, this is going to give you at least the like, oh, that thing is the ugly, bad performing thing, let's go look at that. And then once you start really getting into tweaking where you're trying to get past like 10,000 requests per second on each pod type problems, that's where you start really getting into these metrics and these tracing and all this kind of stuff.
Sort of the black swans.
Right, it's black swan is a good way to put it. It's not quite dragons, but it's angry birds. But it's there's 90% of your performance problems. What's the old saying? Don't optimize too early. So 90% of your performance problems, wait till they happen, and then you're going to see in the logs, you're going to see in the timing that, oh, this thing is taking way too long, go solve that one. And then once you have all those solved, then you can start shooting for that last 10% or that last 2% or whatever, which is when you really get into the tracing and you really get into the metrics and you really get into a lot of those tools.
For distributed applications, do you have a recommended platform or tool chain for doing metric aggregation? So if you have a front end that has 20 different pods associated with deployment, how do you get meaningful metrics that tell you about the application as a whole? How do you get meaningful metrics about individual instances of the application of the front end and how they're performing? Like, do you use StatsD? Do you use Prometheus? Where do you decide to aggregate? How do you make those decisions?
in Kenzan, we don't really use StatsD a whole lot, but we've used Prometheus, we've used, what's the other database?
So I was gonna say like our one that I think we've championed because a few of our clients has been Splunk. That's just been but it's super, super expensive.
I mean, the problem with Splunk is it's a document-based data store, so it doesn't do traditional time
Right.
series database
Yeah.
aggregation.
No, so Splunk is more the logging. SignalFX, a couple of our clients use that, which is more the metric side of things.
Okay.
Datadog is another one. Prometheus is one that runs on site. I'm drawing a blank on the database name, but it's I think it's InfluxDB and
InfluxDB
Grafana strapped on top.
With Telegraph and
Yeah,
the Telegraph stack.
We've seen a bunch of those things. We don't really have any one here's the magical solution.
Analytics, I think, really matters more. It matters a lot to us, but those analytics generally are more used by the business side. That has always been decided by the client almost. You know what I mean?
Yeah.
They know how much they're going to spend. Are they going to go with open source or not? Do they have policies against that? So I can't think of one that this is what to use.
Yeah, there's a little one that we used at the last place for, not the last deployment I did, but the one before that, that was called server density. And it was very much on par with a software as a service version of Nagios plus the data recording facility when you bolt that in. So it was a really shiny, slick version of that. Basically pulled CPU stats, all that kind of stuff, and we used that just to make sure things weren't falling over. It really, as far as metrics...
I'm more concerned about application.
Right.
So
it really depends on your application. It really depends on what you're doing. It really depends on what you care about looking at. We did a bunch of application stats in the server density one, but we basically put basically wrote a couple of plugins to go pull the application stats out of the applications and push them in. We don't, as Kenzan, have a particularly here's your golden nugget one that you can use. It really depends on what you're doing and what you're comfortable with. Like I say, we've got
We've
got a couple.
Right?
Yeah.
Are you entirely Elasticsearch shop, and every front end service is doing nothing but logging into Elasticsearch as your magic backend? It's going to be different.
Right, you're going to use something more like CloudWatch that's built into, not CloudWatch,
I think Grafana or Elk, start building an Elk stack based on that. Then you don't have to worry about it falling over.
AWS has a cloud something or another. It's not CloudWatch, it's the other one.
CloudTrail.
No. CloudWatch is the metrics. CloudTrail is the logs.
Yeah.
CloudWatch. If you're all AWS shop, use CloudWatch. It's right there. There's something similar in Google. If everything's in GCP, just use it. It's probably going to be cheaper to use what's built in and a hell of a lot easier to set up. To just go turn it on and start pumping data to it. But if you're an all open source shop,
well, if you're doing instrumentation of your application, turning on a remote service doesn't help you. You still have to instrument your application in the format that they expect. You still have to push it out, and you have to have a strategy for how you're going to aggregate that data together.
And you have to know where your bottleneck is in the first place. You could over-optimize.
I'm not at all concerned about the infrastructural concerns of where are my bottlenecks. That's what sampling is for, right? My concern is do you aggregate at the instance? Do you aggregate at the application? How do you make those kind of design decisions when you're making an application on?
When you start talking design decisions like that, it entirely depends on your requirements, right? So when I was working on boxes that went on airplanes, you had to do all of your aggregation, all your metrics calculations on the airplane before you sent it down, because you had the equivalent of a T1 link to the ground that was working about 50% of the time. So everything happened on the airplane and then sent down, errors and warnings got priority, everything else was trickled down as it could be. But then, with some of our current clients, they don't do any aggregation on the pods. They just push that off to the metric server and let the metric server aggregate everything and cull through the data and all that kind of stuff. They just shove the data over there and let that system take care of it, because these systems are trying to hand out requests as fast as they possibly can. So it really depends on what you're building and where you need that information.
So I'd say always the instance level, right? Always monitor your worker nodes. And when I think instance versus application, I think standard EC2, are we running Packer and dropping instant, you get a full VM and we're going to scale up these VMs, not Docker, nothing. You get whole virtual servers versus worker nodes.
So I guess where I'm specifically coming at is like if I have 10 different instances of my front end running on Kubernetes, right?
Right.
If I decide to sample my data and do aggregation at the instance level, then that guarantees statistically that I cannot re-aggregate at the application level. Because I've aggregated at the at the instance level, you can't re-aggregate aggregated stats. And
So,
yet
so you need to do like
reasonable
red,
image
black,
of
and or
application
blue,
security.
green, right? And pull off
No,
or
no, no.
carry, right?
I
So-
think what
so
you're
the question
asking
is,
it is
like-
at what point do you basically at what point
Should I care about the application health or should I care about the instance health?
You should
When
care about
both.
that.
When I'm writing application monitoring, like when I'm writing instrumentation for my application, which of those two do I choose, and how do I make the decision
If you're
given what my application looks like?
if you're
Do I care about the instance or do I care about the service?
if you're instrumenting the application, you care about the application. If you're instrumenting the instance, you care about the instance. But I
But
believe
it's the same code base.
no.
No, I guess define application. By application, you mean service or the whole of multiple
So
services?
let's say I'm writing a Golang application. It's just it's a front end and it communicates with the back end API and it just
Right.
interfaces that.
Okay.
And I can scale it to I can have one node running, or if I have a lot of demand, I can have 10 nodes running.
So
I
right
can have
scale.
10 instances running. So if I run statsd and I aggregate at the instance level, if I put the instance name in the metric name, then once I get a P95, I can't then say, okay, give me the P95 of all the instances, right? Statistically, mathematically, you cannot do that.
Disagree. But
You can't take a P95 of P95s. It's statistically inaccurate.
you don't do that.
You've taken away all of the sampling data, so you don't know how rich the source is. And so if you take a source that has 20,000 samples and a source that has 10 samples, they both have one raw numeral. And if you aggregate that and take a P95, then you have something that's entirely false. It's not a P95 of the actual raw data.
Right, you don't stack things like that, right? You don't P95 of a P95. You take your
So
entire
how do you
data
make a
set
decision
and
of
you
what layer do I put the P95?
all of them. You take your raw data, you lift it up into your metric server, and you have your raw data there, and then you can calculate it. All right, on this one, I can calculate that raw data. I can decimate it this way on a per instance level and see what my P95 is for each instance. But then I can also take that raw data and I can decimate it in parallel over here and get a P95 across the cluster.
So
Okay.
if I can throw like a kind of a specific example, like we have 60 different nodes that are running the same exact service,
Okay.
and we have Prometheus. We use Prometheus for everything because it's awesome,
Sure.
and we just absolutely love it. And we get data from the instances, the nodes themselves, but not related to the application. We'll get the applications based on the pods that are running in them. So we may have 2 or 3 pods running on a particular node, but we'll just get individual data from, we'll basically scrape the Prometheus data from each one.
Sure.
And then we actually postpone doing any sort of aggregation or computation until we actually get it to perform, until we're actually displaying it. And that's where we'll put, like, for instance, sums and averages and things like that.
So you don't use any histograms or anything?
So we don't
Or
know.
summaries or?
You do them. You do them once your data is off in a data store.
Yeah. We do.
Well, I mean, doing
pull-
you can't do histograms based off Prometheus data after the fact.
So the
Prometheus doesn't store rich enough data.
Yeah, but we have Prometheus. So like we use histograms in the Prometheus requests that we're doing to capture the data, and it's good enough for us to be able to give us kind of a thumbs look of what we're doing.
Okay.
I mean, it's not. Yes, it's probably not mathematically accurate, but all we're really looking for is sort of a thumbs up, thumbs down kind of situation for our particular data that we're like requests. How long are the requests taking? If I see a bunch of requests that are taking a long time, that's a red flag for us. You know, and it gives us enough information.
But
at
you do
the
a
end of the
histogram
day.
at the instance level, and
Yeah.
then you do a summary based off those
Actually,
histograms.
no. We actually collect all the data together, average all the data across the system, and then do an average of that.
Okay.
So I'm gonna
So
jump in
if you
here.
wanted, there's something special that only a few tools do that I've seen a lot of people do to really
Rusty?
narrow it down, but it's
2 seconds.
fun.
I want to jump in. I want to thank everybody for coming. and say we're going to go ahead and shut this down and then let the conversation continue not on the YouTube stream. But I just want to thank you all for coming, and if there's any pizza left, grab it, and then we'll probably push out of here in, I don't know, 15, 20 minutes once we're cleaned up. So, thank you. And then, I'm not sure yet if we're having one in September, but we'll definitely have one in October. So, keep posted on the meetup for that.
And that's the circuit breaker talk in October?
That's in early October, but it's not this meetup.
Okay.
I'll make sure Craig posts that one on there, so
Please
you guys
do.
can get information about it. But that one, I think, is at a different meetup, or I think it's at a different meetup. I think it's one of the Node.js based meetups. But he's also going to, after that, he's going